Today's video deals with deductive reasoning. We're going to look at the conditional statement, if the sun is out, then the weather is good. Now, the sun is out is our hypothesis. And the hypothesis we represent with the letter P. The weather is good is our conclusion, and we represent that with Q. So symbolically, the way we write this is P arrow going to the right and Q. It means if P happens, then Q happens. If P, then Q. If you want to use a symbol for negation, you use this little tilde right here. So if you want to write the converse of this statement, which means to switch the hypothesis and conclusion, if Q, then P, we would say if the weather is good, then the sun is out. Now for the inverse, which means to negate the hypothesis and negate the conclusion and say if not P, then not Q, we're going to say if the sun is not out, then the weather is not good. And lastly, for the contrapositive, which is if not Q, then not P, we would say if the weather is not good, then the sun is not out. All right, so there's an example of the conditional statement, converse, inverse, and contrapositive. Let's move on to our next page. For example, if angle B measures 90 degrees, then it is a right angle. And we want to write if not Q, then not P. Well, angle B measures 90 degrees, that would be P, and it is a right angle would be our Q. So let's negate that. Negate the conclusion. If it is not a right angle, then angle B does not measure 90 degrees. Now, part B of this, write if P, then not Q. So, if P means if angle B measures 90 degrees, then not Q means then it is not a right angle. Okay, now next, the law of syllogism. The law of syllogism says if P then Q and Q then R are true. If they're both true conditionals, then if P, then R is true. So for example, what I'm saying is if it is Tuesday, then the garbage will be collected. If the garbage is collected, then I will be late for work. If I am late for work, then my boss will be mad. So here is our P, it is Tuesday. Q is the garbage will be collected. Again, Q is happening. If Q, I will be late for work is R. So what can we conclude? If I am late for work, then my boss will be mad. All right. So let's see how this works out. What can you conclude if it is Tuesday? Well, if it's Tuesday, the thing that's going to finally end up happening is my boss will be mad. So that's what we can conclude. And what can you conclude if the boss isn't mad? Well, all of this happens if it is Tuesday. So if the boss isn't mad, we can conclude that it is not Tuesday. Let's move on to the next page. For example, you're given that x equals 4, and you're asked what can you conclude if anything. So you're given this statement, if x is greater than or equal to 2x minus 12, then y equals x. So let's see if this first part is true. If we plug in 4, is 4 greater than or equal to 2 times 4 minus 12? Well, 4 is greater than or equal to 8 minus 12. Let's see, I'll just put a question mark here. 8 minus 12 is negative 4. Is 4 greater than or equal to negative 4? Yes. So if that's true, we can conclude that y must be equal to x. And so what's x in this case? X is 4, so y must be 4. This is what we can conclude. So we'll conclude that y equals 4. Now let's move on to the next one. Here we're given that x is 4. So what can we conclude if anything? If x is greater than 3x minus 2, then y is greater than x. Well, let's plug in 4 in place of x. Is 4 greater than 3 times 4 minus 2? Is 4 greater than 12 minus 2? So we get the statement 4 is greater than 10. Is that true? No, this is false. So we can't really conclude anything at all about this because we were told that if x is greater than 3x minus 2, then y would be greater than x, but we don't know that. So, or I'm sorry, we know that x is not greater than 3x minus 2, so we really can't conclude much of anything about that statement. So thank you very much for joining me. I will see you next time.